Here, in the particular problem, we are going to perform a free vibration analysis of Audi car bumper, and the material with which Audi car bumper is prepared is carbon fiber composite material. And remember, this material we have taken for representative purpose only. And if we want to analyze composite materials, then there is a separate procedure and modules for analyzing composite materials inside Ansys workbench. So in this problem, what we are going to do is we are going to try to find out the first 5 natural frequencies and mode shapes of this Audi car bumper instead of default 6 natural frequencies. So once we find out the first 5 natural frequencies and mode shapes, then we can try to find out the frequencies of this Audi car bumper in a particular frequency range. Let us say somewhere around 100 Hz to 1000 Hz.
In order to perform a model analysis on a car bumper, we are going to drag this model onto the project schematic, and once I drag it to the project schematic, now I am going to go to the engineering data. Here, as I told you, the bumper is made up of this carbon fiber composite. For that purpose, I am going to go to engineering data sources, go to the composite materials library. As the carbon fiber is a part of composite material library, then I am going to select this epoxy unidirectional 395 and I am going to add it to my current analysis. Now go back in project, then right click on the geometry, import geometry and select this from here. Now open Ansys mechanical module and here is our model. So remember, in this car bumper model, there are two types of bodies. One is surface body, another one is solid body. So for the surface body, we need to define some thickness in Ansys mechanical. For that purpose, select this surface body. Then we give the thickness of 10 mm in the detail window. So now once we have defined the thickness, see for this surface or top part, we are applying carbon fiber as a material. So change its material to epoxy carbon. Now see, there are 3 solid parts for which by default structural steel is already aligned to them. So connections are already generated. Now generate mesh. It is a hybrid model, it will take time to mesh. See, even with the default mesh, we have got a very good mesh. But see, as an experienced engineer, we should be able to see whether the mesh is accurate enough or not. Now go to the model tab and click on insert. Select fix support and we are going to fix these two faces. Just zoom it and select these faces. And press apply. Now we have applied the required conditions. Now go to the analysis settings. If we just directly solve the problem, we will get the first 6 natural frequencies for mode shape, but we need only for 5 natural frequencies. See here, the first option is maximum modes to find it. It is asking us how many number of modes do we want the computer to find, whether it may be 6, it may be 10, it may be 20, maybe 30, maybe 40, or it may be even less. So for now we change it to 6 to 5 and press enter. Now solve the problem. Remember, this number of natural frequency is to be ease dependent of the further analysis for which you are going to take this model analysis as a reference. For example, further you are going to perform harmonic analysis in which we need to find out more than 11 or 12 frequencies. Then you will type 11 instead of 6 here. Now see the solution, we get 5 frequencies only. Go again to this analysis setting. We can also increase or decrease the number of modes. Increase it to 11. Now solve the problem. If we are increasing the number of modes to find the number of equations are going to increase and solution time also increases. Here we are first 11 modes here. If we want to see how this bumper is deforming on this mode, right click on it and select create mode shape. And here is our all mode shapes and evaluate the results. Now we can animate to see the deformation on this particular frequency. We can also check the frequency from here and check on which mode we are on. Here we are on mode number 5. Again go to analysis setting and decrease it to 6. And now if we want to find out the natural frequency between the two ranges only, then select this limit search to range box and select yes. So in range we need it from 600 Hz to some 800 Hz. Now solve the result. See here we get the 6 frequencies that are present between this range. Select all option, right click on it and select create mode shape and evaluate all the results. And we can check the deformation one by one. So this is how we can perform the analysis on a car bumper.